Here the focus from my class is synthesis. Don't worry too much about the mechanism here. The reaction of carboxylic acids with lithium aluminum hydride is rather unique. There's several plausible mechanisms you can draw, and it's kind of just a little bit all over the place for sophomore organic level, organic chemistry. And the reaction of carboxylic acids with borane is quite complicated. They're still studying this, and I saw a paper come out just recently within the last few years where they predicted all of these, possible mechanisms. Okay, so it's quite complicated, and I just suggest you learn the reactions. Okay, so first things first, if you have a carboxylic acid, okay, and you add lithium aluminum hydride to this, followed by water, you'll form the primary alcohol. LAH is lithium aluminum hydride. We sometimes write it like this, okay? And it has this, Lewis structure that we've seen before. This will come up again later on in this chapter, but the curved arrow reaction mechanism will be very straightforward and will be just like all the other derivatives, okay? So pretty much we just write LAH above the arrow to keep it simple, okay? Now please do not confuse this with the Jones reagent. If you take a primary alcohol, you can convert this to a carboxylic acid, okay, by an oxidation, okay? So LAH does the reduction. You're basically adding hydrogen to the molecule, and the Jones reagent is an oxidation. You're adding oxygen to the molecule, okay? So that's the simplest way to think of oxidation and reduction. Borane can also be used to selectively reduce carboxylic acids. So if we have something like this and we add borane, okay, BH3 is called borane. It's stabilized by a THF, which forms an adduct with the borane. But anyways, that will selectively reduce the carboxylic acid to a primary alcohol, okay? And strangely enough, it does not react with the ketones or the aldehydes, okay? So it's a selective reducing agent, okay? If I treated this molecule with lithium aluminum hydride, what would I get? I would get reduction of the ketone and the carboxylic acid, okay? If I tried to reduce the amount of lithium aluminum hydride, I would just end up with mixtures of things. But here's the product that you would get. So remember, lithium aluminum hydride reduces ketones to alcohols, and it also reduces carboxylic acids to primary alcohols. Okay, so that's a reaction you could do with lithium aluminum hydride. Borane will selectively reduce the carboxylic acid. Let's do problem 11 here in the book. Now, I'll give you a major hint. When you see problems like this, you want to think carboxylic acids. This is on your carboxylic acids homework or an exam or something, so you really want to think about carboxylic acids. So when you think backwards, take your alcohol that's shown here and think about what carboxylic acid this can come from, okay? And then think about how you can go from your starting alkyl halide to a carboxylic acid. And then bingo, you should be able to remember that from the flashcards that are in your back pocket right now. So the way we would do this is we would take the halogenated aromatic ring. And remember, cyanide won't react with this because it's aromatic. What we want to do is treat this with magnesium in diethyl ether. We would want to add some dry ice, for example. and then acidify the reaction mixture with aqueous hydrochloric acid or something like that. And this would get the benzoic acid, okay? And then we could reduce that benzoic acid with LAH and water. Okay, so this involves two synthetic transformations. We're going from one functional group to another, and then the carboxylic acid to the alcohol. But there's a lot of steps there, 1, 2, 3, 1, 2, okay? So in part B, we're interested in going from this toluene to benzyl alcohol. How are we going to do that? Once again, think backwards. Alcohols come from carboxylic acids. Benzoic acids can come from toluene. So how are we going to do this? We take toluene. We treat this with potassium permanganate, okay, to give benzoic acid. That's like a 3 or 4 hour lab. We don't do this in the class because it just takes so many hours. And then what you do is you reduce this once again with LAH and water, okay? So that's it for this chapter. Obviously, you want to try the additional practice problems in the textbook, but that's the basics of it. Thanks for watching, and please like and subscribe.